Hello, I'm Alex and I'm the audio engineer for Find Your Light. This video is my workflow on how I created the sounds for this game, and it can be split into the 3 different computer programs that I use throughout the whole journey. First of all is Pro Tools, which is used for music asset creation. The synth and orchestral background music is created in here, and it is also used to prepare the sound effects. Then Audio Kinetic Wise is used for audio programming. This is a middleware that handles the audio engine and is integrated with the game engine to work with its code. This is where we add most of the effects to our music and sound effects. Then Unreal Engine is the final touch where we merge the sounds with the game code using the blueprint system in Unreal Engine. For the Pro Tools section, I originally had 4 ideas and I went down to 2 ideas which I incorporated in the main theme as different variations. This is meant to be an exploratory music, so it's very lighthearted in nature at the start with a few strings, and then later it picks up by adding some drums, as I can show here in the folder here. It picks up in depth and adds more drive to the whole piece. So the first variation would be the harp sound, which I used the East-West Symphonic Orchestra. This is a long harp pluck sound, and it's also complemented with some legato violins, which are shown here. And then the second variation would be a dark bell tone, and I used massive Native Instruments, a wavetable synth, to create this sound. Essentially, I use the envelope to create an ADSR that looks like this, which has a very short attack, and the decay level is turned all the way down, so it's essentially into no sound right after the button is released. As for the effects, I use resonance, which is shown here in this dial, and it makes it more bright sounding. And to increase that effect, I use the EQ to add a high shelf to the sound to give that airy effect to the bell. This dark bell and harp music is used for when the game is in a calm state, but when the player gets hit by a spotlight, it changes the music to add more depth. And the way I did this was adding drums, like I said before, and also adding some more instruments. One of the more noticeable ones were the addition of a male choir, and this is done using East-West Hollywood Choir's Diamond, in which I used the word builder function, which I can show here. So this has a Votox system where I type in some syllables that are that will spell out the word, in which case here it says magic. I can figure out each single syllable and alter the different lengths and pronunciation of each letter. For example, here I made the E elongated to accentuate that particular sound. Moving on to Wise, the easiest way to explain this program is to understand its hierarchical structure. This is split into the actor-mixer hierarchy and the interactive music hierarchy. The first one, actor-mixer, is used to put the one-shot sound effects, such as the birds sounds and the flickering light sounds. The birds I put into a random container, which randomly pulls the birds from this list of bird sounds. So for example, if I press play again, it'll play a different sound. Now the real challenge is the interactive music hierarchy. And this starts with the music switch. This basically tells the Wwise program which music to play when the game is in which state. And to make the states, we go into game syncs and go into state group and create these states that are shown here. Now, the next step in the hierarchy, or the children of the music switch, would be the calm cutscene and red SL music playlists. And going into the calm playlist, we can see the structure of the sequences that are played. So we start out with the sequence continuous, which is basically telling the program to play Idea for Dark Bell and serves as an intro. Next, we go into a branching random continuous, and it can randomly choose any one from each one of these branches. And this loop count is set into infinite, so this basically keeps on looping, forgetting about this Dark Bell intro. It can choose strings, a harp, a bird sequence, or it can choose another nested sequence continuous, which plays the Dark Bell variation 2 and Dark Bell. Going inside this playlist container is the sequences themselves. Now, each sequence has a different number of tracks. For example, in this Idea for Dark Bell, we have 5 tracks playing the Dark Bell and the Dark Pluck instruments. Now I can layer this by adding some flair to the music. For example, a tremolo violin, a reverse bell, and a Penderecki violin. And then I can make another variation of this by removing the Dark Pluck instrument and adding some effects, such as a stereo effect on the violin tremolo, a pitching down effect, down an octave on the same tremolo, and then extra reverb on the Penderecki violin. Now, Unreal is the thing that glues everything together. And first of all, I set up some volumes that trigger the music state in Wwise. The floor and balcony are responsible for setting a calm state. And then the red SL trigger sphere is for setting the intense state. Now we can have a closer look into the trigger floor blueprint. This starts with the event actor begin overlap with the trigger box, and it checks for the player's character blueprint, and moves on to the state set state node, which is a node that communicates with Wwise. Here we set the state group to calm, and to illustrate my point, we can go into Wwise now and play the red spotlight music. Now, when I set the state group to calm, it should slowly fade into the calm music soundtrack. Secondly, we have the reverb audio zones, activated by entering one of the 2 boxes underneath the buildings. This uses the set RTPC, or real-time parameter control, node to alter the underbuilding RTPC. In Wwise, reverb is applied to the effects panel of the audio bus for music, and in addition, the low-pass filter and bus volume also change relative to the same RTPC. Let's play the sound to simulate this. 0 is a fully immersed reverb effect, and 100 is a dry signal with no reverb. The graph for reverb is a simple crossfade between wet and dry levels, while the LPF is an exponential since frequency is a logarithmic scale, and the bus volume is in a sine constant power fade. Thank you for watching, and if you have time, be sure to check out the video that my collaborator Kez has made on the animation work that has gone into this game.